Good morning. I'm going to try to prove the Pythagorean theorem. Of course, that you're familiar with that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Well, let me see if I can draw me here a triangle. And let's get started over here. Let's start right about here. Let's get my point right there down, and then I'll make a point over to here, and then a point over to here. All right, good. Now let's first label this. Let's label this right here as A, B, and C. Okay, according to this right here, then according to his theorem, it said a squared plus b squared is going to equal to c squared. So that's something here we want to prove. Prove a squared plus b squared equals to c squared. And we were given a, let's see, let's call this right here, this would be B, this would be C, and this would be A. So we're given triangle ABC is a right, IGHT, angled triangle. Okay? All right. Now, that's what we want to prove. Let's put some statements and things over. Let's get that line a little over here, there, and make that down. Okay. First thing, we're going to use the Garfield. President Garfield came up with a proof to do this. And let me go back over here. Come on, wake up, wake up. All right. So I'm going to go up here. I went A, so I'm going to go all the way up here to make this B. Be 1, 2, 3, 4. Is that right? That ought to be about right. Okay. And then I'm going to go out 1, 2, 3, right about there. We're going to get that straight as I can. And then I'm going to bring this guy all the way down to here. Okay. And I'm going to connect this point to that point. Okay. Now, let's go back over here and write in that if this is A, then this right here is going to be, you see the length right here of this case right here, this is B. If I bring that up over to here, that's going to be the same thing. So I'm going to put B right here. So this length right here is B. The length here is going to be A. Obviously, this is C. So, like we did on this proving the Pythagorean theorem with a square, for the Garfield method, we're going to do over here. The first thing is we have down here is 1. We have the given that we have a triangle ABC is right. And that's given. Okay. And then number 2, statement number 2. We know that the area of the area of the entire, this right here looks like a trapezoid, right? We got a parallel. The base, the two bases are parallel. So then the area of, we're going to find the area of the trapezoid is going to be equal to the elements of that using partition. In other words, the elements are going to equal to the sum of the sum of the elements is going to equal to the whole. So the first thing is, let's go ahead and find the area of the trapezoid. And we know the area of a trapezoid is going to be what? It's going to be 1/2. Oh, what happened there? 1/2. The height of this thing right here is A plus B. All right, so that's going to be A plus B times the what? The two bases added together. Base 1 plus base 2, which is actually A plus B. And we know that's right there. We can do that right there is the area of a trapezoid. Okay, that's the area of a trapezoid. And then we also know that number 3, that by the same area of this right here through partition is going to be equal to the addition of all those elements. Okay, the addition of those elements are. Now we know that this triangle right here, which has a base of B and a height of A, this one right here has a base of that. So you essentially have 2 triangles that are same. So that means we got 2 triangles times 1/2 A, B. All right, so that's our 2 triangles, plus the area of this triangle right here is going to be what? It's going to be plus 1/2 the height, which is C, times the base, which is C, which is going to be C squared. All right, and we'll make 3 here as the for consistency. And then this right here again, right, this is going to be the, we can call this the area of a trap. Via partition, because it was the sum of the elements. Okay, now I'm going to bring this over here, and I know that A is going to equal to A, correct? Of course they will be. A equals A, and then through substitution, I know that I'm going to put this over here, that 1/2 A plus B times A plus B is going to equal to 2 times 1/2 AB times, or plus 1/2 C squared. Okay, I know that because that, this being this right here, number 4. Oh, how'd that happen? And the reason for that, I'm essentially substituting these elements. So let's just call that substitution. S-U-B-S-T-I-T-T-U-T-I-O-O-N. Oh, lousy handwriter. All right, 5. So let's go ahead and simplify this. So we know that A squared, so that's going to end up being 1/2 A squared. We just use FOIL, okay? Plus 1/2 2AB plus 1/2 B squared using FOIL. Then here these 2's cancel out, so that's going to end up being AB, correct? And this is going to equal to, plus 1/2 C squared. Now, I can, this right here becomes 1. All right, so step number 5, all right, all I did was simplify the equation, all right? Now, I'm going to subtract AB from both sides because this 2 and the 1 becomes 1 AB, so I subtract AB from both sides, So number 6 is going to look like 1/2 A squared plus 1/2 B squared is going to equal to, that cancel out, it's going to be equal to 1/2 C squared. So number 6 is going to be by what? All I did right there is subtracted. Subtraction. Okay. So step number 7, all I've got to do is what? I just multiply both sides by 2. So number 7 is going to be multiplication. Multiply. So if I multiply both sides by that, I'm going to end up with being a squared plus b squared is going to equal to c squared, which, guess what? That means right here, we just proved what we were seeking to prove, that, as it says right here, that the c being the hypotenuse, that the square of the hypotenuse is equal to the sum of the squares of the other two sides. And that was through President Garfield, who's the one who was a proponent of this. That concludes this. I hope you have a good day. Bye.